So we're moving on to our triangle lessons, and there are tons of triangle questions on the SAT, but there really are only a few rules that you need to know. The first rule is something that you actually probably don't remember, and it's finding the third side of a non-right triangle. If they were to tell you that this side is 7 and this side is 10, and they wanted to know one possible length of the third side of this triangle, you might find this in the grid-in section, because we will never be able to know an exact length of that third side unless we're doing trigonometry, which we know we don't need on the SAT. But what you want to remember is that the third side of a right triangle has to be less than the sum of the other two sides and greater than the difference of the other two sides. So the sum of the other two sides in this case is 10 plus 7, so we know that this side has to be less than 17, and the difference is going to be 10 minus 7, which is 3. So this third side, the only thing we know about it is that it has to be greater than 3 and less than 17. You want to remember that it cannot equal 17 and it cannot equal 3, it's just going to be between them. So if they ask for the greatest integer value of this side, it would be 16. The least integer value of this side would be 4. The next thing that you want to remember about triangles is our right triangles. So we just dealt with our non-rights, now we're dealing with our rights. And there are 3 special right triangles that you just have to memorize. Not only do they give them to you on the front of your math section, but it will really save you a lot of time if you memorize them. The first one is the 3, 4, 5 and its multiples. So for example, if you remember the 3, 4, 5, if you multiply all of those sides by 2, that's going to give you a 6, 8, 10. If you had multiplied 3, 4, 5 by 3, that's going to give you a 9, 12, 15. So anytime you see things in that ratio, always remember your 3, 4, 5. The next triangle that you need to know is the 45, 45, 90. That is an isosceles right triangle. And basically what you know is that the two legs are going to be equal. And so if we call those both x and x, what you want to remember is that the third side is going to be equal to x square root 2. So for example, if this side is 4, we know that that side is also 4, and this side is going to be 4 square root 2. If they tell you that the hypotenuse is equal to, let's say, 8, that means you set x square root 2 equal to 8. And to find x, you divide both sides by the square root of 2. So therefore, each of the legs is going to be 8 divided by the square root of 2. If you don't like having a radical on the bottom of your fraction, what you want to do is multiply this by square root over 2 over square root of 2. So now you have 8 square roots of 2 over 2, which is just 4 square root 2. So either way you want to do that, you can either use this leg to find the hypotenuse, or find the leg from the hypotenuse. The last special right triangle that you need to know is the 30, 60, 90. And the thing that you want to remember about that is that the side opposite our smallest angle is always going to be the shortest side of the triangle. So in this triangle, our smallest angle is 30, so the side opposite 30 is going to be our smallest side. So that's going to be x. The side opposite our 60 is our next smallest side. That is going to be x square root 3. And then the hypotenuse of a 30, 60, 90 is just going to be 2x. So if you remember that formula, you'll be able to find the sides of any 30, 60, 90 triangle based on these 3 figures. The next thing that you need to remember about triangles is the Pythagorean theorem. And I really don't even think I have to go over it because I'm sure you've used it a million times already. But you're going to probably use it another 1,000 while you're practicing for the SAT. So just remember that A and B have to be the legs of the triangle. and the legs are just the two sides that make the 90-degree angle. The c squared represents our hypotenuse. So anytime you want to find the third side of a right triangle, you use a squared plus b squared equals c squared. The last thing that you need to know about triangles is similar triangles. All that means is that the sides are in the same ratio and that all of the angles are equal. So for example, if we said that this triangle had lengths 3, 4, and 6, and they told us that one of the sides of this triangle was 24. But they didn't tell us which side, but they did tell us that it's similar. What you want to know is that we could pick any of those sides. So let's say we picked this side. When we know that there's the same ratio of sides, what that means is that to get from this side to this side, we multiplied by 6. Therefore, you have to multiply by 6 on every single side. So to go from here to here, we multiply 6 by 6 and get 36. To go from there to there, we multiply 3 by 6 to get 18. And so that is how you would get the sides of one similar triangle from another. In this similar triangle question, they're asking us for the shaded area. Now, if they told us that this angle is a right angle and that DE is parallel to BC, what you want to realize is that if that's 90, now this also has to be 90 because they're parallel. So looking at this, we know that when we have all of the angles the same, and we know that they're all the same because in this small triangle, this angle and this angle are equal. This angle is the same for both this small triangle and our big triangle. And then therefore this and this are going to be equal because the lines are parallel. So now that we know that all the angles are equal in these triangles, we know that we have similars. So looking at this, if they want us to get the shaded area, if this side is 6 and this side is 10, we know that this big side of the big triangle is 25. So the ratio of the sides of the little triangle are going to be in the same ratio as the sides of the big triangle. So to go from 10 to 25, we multiplied by 2.5. So now to go from 6 to this side, we're going to multiply by 2.5 as well. And that is going to be 15. So now what we can do is, in order to find the shaded area, we do the area of the shaded is equal to the area of the whole minus the area of the unshaded. And so the area of the whole, we have its base, but we don't have its height. However, what we do have is that this is a 3, 4, 5 triangle times 5. So this is 3 times 5 gave us 15, 5 times 5 gave us 25, so therefore 4 times 5 is going to be 20. So the area of this big triangle is going to be 15 times 20 divided by 2. So that would be 150. The area of the unshaded is also a triangle, and we know that this is going to be a 3, 4, 5 times 2. So 3 times 2 is 6, 4 times 2 is going to be 8. So the area of this triangle is going to be base times height, so 6 times 8 divided by 2, and that gives us 24. So 150 minus 24 gives us 126. And that is an example of a pretty tricky shaded area question because it involves similar triangles as well as special right triangles. So now go ahead and try your triangles drill and see how you do using all of these formulas.